doing with all of this? We're going to talk about identities. So we're going to use all those tools that I just showed you before of how to kind of manipulate expressions and make them into something else. So in an equation, you begin with we always want to say, pick the more complicated side. Okay, so look at the equation, pick the one that's super complicated, and you're going to manipulate that side using all those little tips and tricks I just showed you to get to the other side, to arrive to what the other side is. And you don't want to treat this identity like an equation to solve. Solving an equation gives you an actual answer. With an identity, we're just showing how things are equivalent. So for example, establish this identity, these two. So what an identity means is we want to show that this is equivalent to this, okay? So if you go back to the problem we just did, we just showed that two things getting multiplied together, cotangent theta times secant theta, was equivalent to cosecant theta. So what we're trying to show is that these two things are equivalent. So what we do is you pick one side, and then we're going to manipulate that side until we get the other. Now, the side I always pick is the more complicated one. Clearly, on this one, the left-hand side is the more complicated one. So start there. All right, 1 minus cosecant theta times sine cubed theta. So what I do, like notation-wise, is I'm going to tell the person that's looking at my work which side I chose. So this is the side I chose to solve. Now I'm going to manipulate this until I get to this side. We can't move things around on either sides of the equation. You literally have to pick one side of the equation, and that's the only thing you use to simplify it to get the answer that they're telling you. So we already know the answer I want. I want that as my answer. So now let's figure out how to get there. First things first, I'm going to change everything to signs. So I'm going to rewrite cosecant as cosecant is the same thing as 1 over sine. And then that's still sine times sine cubed. Oh, well, that's kind of cool because those will cancel with one of those. So I'm left with 1 minus sine squared theta. And we've been using those Pythagorean identities a ton. So we know that 1 minus sine squared is equal to cosine squared, which is exactly what I wanted to show. So I've now proven that. So I just put a little check mark next to it once I get that. Okay, so let's look at letter B. So for solving letter B, let's start out with either side. I feel like they both look kind of complicated. So sometimes when I see these, what I decide to do is to do the side that has a more complicated denominator, because usually doing that trick of multiplying by the conjugate really helps us out. So I'm going to show, again, that this is the side I'm picking to manipulate. So that's what I've written on the left-hand side. All right, so let's take that and multiply by the conjugate of the denominator. Okay, so when I do that, I'm going to get cosine theta on the top times 1 plus sine theta all over. When I FOIL out this bottom, we're going to get 1 times 1 is 1. 1 times sine is sine. Negative sine times 1 is negative sine, so those cancel. And then negative sine squared. So I'm left with 1 minus, I'll use the right. 1 minus sine squared theta. Okay, so at this point I kind of take it, I stop and I say, okay, what do I have here that I need here? Well, sweet, I've got that 1 plus sine theta on the numerator, which is what I need for my n numerator. So what I need to do is get rid of this cosine here and get a cosine in the denominator. I think we can do that because when I look at that denominator, so to get a cosine in the denominator, again, using that Pythagorean identity, 1 minus sine squared is cosine squared. And then this cancels out with one of these, and I'm left with 1 plus sine theta all over cosine theta, which is exactly what I wanted. So I've just shown that this is equal to this. So do you kind of get the gist? For an identity, what you do is you pick one side, and you manipulate that side using those tricks that we did earlier until we get the other side. So why I kind of nerd out on these is that it's like a puzzle and you have these tools to use and you know what the answer should be. So it's kind of fun because you just try stuff until you get what you want. All right, second one. Whew, okay, so clearly on C, the left-hand side is harder. So let's start with the left. All right, So first thing I'm going to do is actually write that side out, without doing anything else to it first, just so that I've stated exactly what side I'm going to work with. All right, so first thing I'm going to do is change everything to sines and cosines because that usually helps. So that's cosine over sine, and that's sine over cosine. All right, kind of yuck. So let's see. There's a couple different things we can do. Some of them will lead us to the right direction, some won't. And to be honest with you, I'm not looking at my answer key for this. I want to do this without that so that you guys can kind of see how I figure these out in my head. So what I think I'm going to do is I'm going to try this. I'm going to distribute that sine theta through and see what happens. So when I do that, I get sine theta times cosine theta all over sine theta. And then here I get sine squared theta all over cosine theta. Okay, that doesn't do that much for me, does it? All right, let's do common denominator because I see that I have two terms here and I need to get my answer in terms of one term. So let's do a common denominator. So that common denominator is going to be sine times cosine. So I need to multiply this side by cosine over cosine, and I need to multiply this side by sine over sine so I can get that common denominator. All right, so that's going to give me sine theta times cosine squared theta all over sine theta cosine theta plus sine cubed theta all over cosine theta sine theta. Okay, so I just got a common denominator, so now I can add these together and I get sine theta cosine squared theta plus sine cubed theta all over cosine times sine. So I'm in like better shape where at least now I have one term, but it's like super gross. So let's keep on going. I'm totally going to run out of space. I'm going to go over here. All right, so that is going to equal, let's factor a sine out of the top. So that's going to give me sine theta times cosine squared theta plus sine squared theta. And then on the bottom, I still have that cosine theta, sine theta. Oh my God, sweet. Hopefully you guys see it, maybe. What's cosine squared plus sine squared? That Pythagorean identity we've been using. It's just 1. So this is sine theta times 1 on the top because I can replace this with a 1 over cosine theta times sine theta. Bam! Sine thetas cancel out and we're left with 1 over cosine theta, which is secant theta. Sweet. I'm sure there was a quicker way to do that, but I really want to show you guys like how I do this with my brain so that you can see that there's multiple ways to do these and you just got to go with it, try it, and see what happens. Oh, lordy lord. Okay, let's see. The left and the right side here both look pretty much the same. So I think in this case, I think I'm going to go with the left side. So write it out. So I'm going to change these to sines and cosines. So I get 1 over the sine of theta minus cosine theta over the sine of theta. Okay, so that gives me 1 minus cosine theta over sine theta. Well, sweet, that doesn't really help me out much right now, does it? So the way I look at this one is, well, I want to get 1 plus cosine theta in the denominator. So you know what? Let's just put it there. And I can do that because as long as I do the same thing to that top part, it's just like multiplying by a complicated number 1. So I knew I needed this in the denominator, so I'm going to put it there. But in order to do it without changing the value, I have to do it to the top and bottom. All right, let's see what happens here. Okay, so when I FOIL this out, I'm going to get 1 times 1, which is 1. 1 times cosine. Negative cosine times 1, so those cancel each other out. And then negative cosine times cosine is going to be negative cosine squared. On the bottom, I'm left with sine theta times 1 plus cosine. Now I'm not foiling out this bottom because I need to keep this here, so I'm going to hope that I can kind of factor this sign out. So I see this top, I can totally replace that using that Pythagorean identity. That's the same thing as sine squared. Sweet, I can totally see it's going to work. And you know what? When you guys start doing these on your own, sometimes you'll try something and it won't work. And that's okay. You just go back to the drawing board and try something else. So this cancels out with one of these. And that leaves me with exactly what I want, which is sine theta over 1 plus cosine theta. Yes. All right, so we're going to do 2 more, and then you've learned these identities. So first, establish these identities. All right, we're going to start with letter E. Clearly, the right-hand side is harder, so we're going to start with that side. So I'm going to state that over here. All right, first thing I'm going to do is remember that this we can do with fractions. When you have one thing in the denominator, you can separate this out. Both of those equal -1/6. So this is just kind of remembering that fraction thing. So I can rewrite this out as cosecant theta divided by sine theta minus sine theta divided by sine theta. So when I do that, cosecant is the same thing as 1/sine. And then that's still all over sine. Sine over sine is just 1. So this becomes 1/sine theta times 1/sine theta, because dividing by sine theta is the same thing as multiplying by the reciprocal, which is 1/sine. So that gives us 1/sine squared theta minus 1, which is cosecant squared theta minus 1. And we know from our fabulous first page where we learned about reviewed our trig identities, we have this identity in here that says that that is equivalent to cotangent squared of 1. So that checks out. Okay, we're going to go to the next slide to do letter F because that's going to take a lot of steps. All right, so we don't care about you. All right, here we go. So left-hand side, obviously harder. Start with that. And take some deep breaths. If you couldn't tell in trig, we do lots with fractions. Okay, so when I look at this one, the first thing that I'm going to do is get everything in terms of sine and cosine. So tangent is sine over cosine. And then cotangent is cosine over sine. Okay. So this is still pretty gross. So you know what I think I'm going to do is let's get it so that I have the numerator as 1 fraction and the denominator as 1 fraction. So let's combine these 2 terms in the numerator. So that common denominator is going to be cosine. So I'll multiply this first term by cosine over cosine. So when I do that, I get cosine of theta times sine squared theta all over cosine theta minus sine theta over cosine theta. I'm going to do the same thing on the bottom. So the common denominator for this is going to be sine. So I'll multiply this term by sine over sine to get that common denominator. So that gives me sine theta times cosine squared theta all over sine minus cosine theta all over sine. Okay, so now when I write this, where this is combined into 1 fraction, since now I have a common denominator, that is going to be cosine theta sine squared theta minus sine theta all over cosine. And then that's all divided by, when I combine these into 1, I get sine theta cosine squared theta minus cosine theta all over sine theta. Okay. So dividing by fractions is the same thing as multiplying by the reciprocal. So this is going to give me cosine theta. And actually what I'm going to do as I rewrite these, I think, no, I'm just going to do it like this. So this is going to give me cosine theta sine squared theta minus sine theta all over cosine theta. No, yeah. Sorry, I keep on second guessing myself. Times the reciprocal of this denominator, which is sine theta all over sine theta cosine squared theta minus cosine theta. All right. So now we're just going to pray that some things start to cancel out here because we need to get to tangent squared theta from this disgustingness. So let's go through, let's just distribute the sine to each of those terms and this cosine to each of these terms and see what happens. So when I do that, I'm going to get cosine theta times sine cubed theta minus sine squared theta on the top. Down here, I'm going to get sine theta times cosine cubed theta minus cosine squared theta on the bottom. Okay, I'm going to end up doing more of my work up here. I'm sorry I didn't leave you guys a ton of space. So notice in the numerator, I can factor out a sine squared theta. So when I do that, I get sine squared theta times cosine sine minus 1. And I can do the same thing here in the denominator. I can factor out a cosine squared theta. When I do that, I'm left with a sine theta cosine theta minus 1. Sweet, these are essentially the exact same thing because cosine times sine is the same thing as sine times cosine. So this is going to cancel out with, this whole term is going to cancel out with that term, and I'm just left with sine squared over cosine squared, which is tangent squared. Sweet. So again, when you guys are looking at these, just know, I know there's a lot, and it's a lot of different tricks and a lot of different things you can do, but you just try something, go with it. As long as you're doing legal math moves, you're fine until you can manipulate it to get it to what you want it to be. This is a great OER trig book that's out there, and they have a whole section over this with a bunch more examples. Khan Academy also has some really good ones too. But in class, we're going to do a bunch of really fun activities with these, and I think this will kind of start to set